How different does this look than the last time we talked about solving systems of equations? It was more like this, right? Just two variables. And remember when I taught you that lesson about solving systems with two variables, I said, I'm just reminding you, because this is just like a prep for what we're doing for Algebra 2, right? This was Algebra 1 stuff, right, with only one variable, like this. But guess what we get to do in Algebra 2? Add another variable, okay? That's what we do in Algebra 2, is systems of equations with three variables, all right? So the first way we're going to talk about solving a system of equations is what? Do you remember the first way that we talked about last week?
Substitution.
That's actually what we are talking about today, but it wasn't the first way from last week. Graphing, right? Do you know how to graph something with three variables?
No.
Yeah, me neither. But I need to talk about it, okay? Because here's the deal. You can only graph something with three variables if you have what? Three axes, right? Well, there's the x-axis, there's the y-axis. That means I have to have a z-axis? Yeah. Here's the z-axis right here. It comes out of the paper. It goes through the paper, right? If I'm trying to draw, so it's basically three-dimensional, right? If I'm trying to draw it on two-dimensional paper, I could draw it like that, right? Can you use your imagination and see 3D space right there? So if I was plotting the point, let's see, because isn't my solution to a system of equations still a point of intersection? And even if there's three dimensions, wouldn't it be like this? 2, 3, 5. What did we call this? An ordered pair. Guess what this one's called? That's really close. That's an ordered triple. And I still go over 2, and I still go up 3, but then I come, what? Out 5, right? So 1, 2, 3, 4, 5. How easy is it to draw three-dimensional space on a piece of two-dimensional paper?
It's hard.
Yeah, it's not easy, is it? Okay? And because you don't even know how to graph this is a plane. It's not a line. This is a line, right? That's a plane. We don't know how to graph that. So we can't really do this by graphing. But the reason I'm showing you what it looks like is because how do we write our answers? As an ordered triple, right? It's almost the same as in two-dimensional space. It's still a point of intersection. Does everybody understand that? So we're still going to write our answers as 2, 3, 5 as an ordered triple. Ordered triple, say it. Ordered triple. Okay, that's how we write our answers. It's the point of intersection in three-dimensional space. Okay, so because we're not doing graphing, then we should talk about what? Substitution. Okay, and that's the way we're going to talk about today. So keeping in mind that that's like where we're going for our answers, how do you think we should start this question? Here's my system. We got lucky on this one, right? Why did we get lucky? We already know x. It already told us x, right? So what should I do with that? Where? Oh, just like right here? Well, what's going to happen if I plug it in right there? I'll know y, right? Okay, so let's do that. So I have x, which is 4, plus y equals -6. So 4 plus y equals -6. How do I solve for y? Whoop. Subtract 4 from both sides. Okay. So what does y equal? Like 10, okay. Oh, so I have x and y, so that's my answer. Dang it. What do I need? I need the z, right? So how am I going to find the z? Plug them both in at the same time? Okay, so 4 times x, which is 4, minus 3 times y, which is negative 10, plus 2z equals 26. Oh, sorry about that. 4 times 4, because that's 4x, plus 3 times y, which is negative 10, plus 2z equals 26. What?
16
Plus 30 plus 2z equals 26. What is 16 plus 30? 46. Okay, 46 plus 2z equals 26. Now we're just solving for z, right? So subtract 46 from both sides. So 2z equals negative 20, okay, and then, so z equals what? Negative 10, okay. Now I'm done? Dang it. What is my answer? Does it really matter what order we write it in?
Yes.
It's called an ordered triple for a reason. What order does it need to be in? X, Y, Z, right? So 4, negative 10, negative 10. Questions? Okay so far? Okay. 2x minus 2y plus z equals 3. 2x minus 2y plus z equals 3. 5y minus z equals negative 31. X plus 3y plus 2z equals negative 21. I didn't get lucky this time, huh? None of my variables are already given to me. So, let's start talking about steps. First of all, I'm only giving you one step on this problem. You already know the steps to do, but I'm giving you step 1. And what's step 1? Don't panic. We're solving this with substitution, which means I have to solve for one variable. Okay? In this particular case, which variable would you solve for? Can I tell you why I would choose this z? I would choose this z because if I solve for this variable, even though this one's a positive and it's by itself, and even though this one's a positive and by itself, it's going to give me already what z equals with only one other variable with it. Now, if there was an x term right here, I would solve for one of these two to begin with. Okay? When you have 3 variables, you're going to have to substitute twice. Okay? When you have 3 variables, you got to substitute twice. So let's solve for this z to begin with, and then we'll substitute twice. Okay? How do I solve for this z? What would I do?
Minus 5y.
Very good. If I subtract 5y from both sides, that gives me negative z equals negative 5y minus 31. And to get z all the way by itself, I would divide both sides by negative 1. Z equals 5y plus 31. Now, what did I say we have to do? Substitute how many times? Twice, right? Now, I can't choose the one that I just used. Okay? I cannot choose the middle one because if I plug it in the middle one, it's just going to give me an equation that's equal. I don't want that. That's not going to help me at all. So I'm going to have to substitute it once here and once here. Okay? So I'm going to start with the top one. 2x minus 2y plus z, which is 5y plus 31, equals 3. Okay, so far? Now I'm going to plug it into the last one. I know I haven't simplified anything yet. I'm just making sure I remember that I need to substitute it twice. X plus 3y plus 2 times z, which is 5y plus 31, equals negative 21. So now I have both places substituted, the top and the bottom. Does that make sense? Okay. So now I need to, in this first problem, I need to combine my like terms, right? So I need to combine these two things. There's nothing to distribute here, so are these parentheses even necessary at this point? No, I just put them there because that's where the z was, right? So I have 2x plus 3y. What can I do with the 31? Subtract it, right? Equals negative 28. Everybody okay so far? Okay. Is there anything else I can do with this equation? No, right? So I need to leave it alone for a second and come over to this one. Now I do have some distributing to do here. So I get x plus 3y plus 10y plus 62 equals negative 21. So I have those two, and then I need to also subtract my 62 from both sides, right? X plus 13y equals negative 83. Do you get nervous when there's numbers like this? Like, quote-unquote, big numbers?
Don't panic.
Have I done anything wrong? Have you caught any errors that I've made? So is this an okay number to have? Yes? Okay. Now I have two equations with just x and y. Isn't this exactly like we did on Friday? So I need to substitute again, right? I need to start over. Like this is a brand new question. So let's solve for this x because it's all by itself. So let's subtract 13y from both sides. So x equals negative 83 minus 13y. Now I have a value for x. So what should I do with it?
Plug it in.
Where do you want to plug it in?
2x plus 3.
Yeah, right there, right? Whoop, not there. Ooh, not there. Right there for x, right? It's x, not y. Sorry. Stray arrow. So 2 times negative 83 minus 13y plus 3y equals negative 28. Okay, distribute. Good idea. Very good idea. 2 times negative 83?
Negative 166.
Negative 166. 2 times negative 13y?
26y.
Negative, right? Plus 3y equals negative 28. Okay, combining my like terms here, and then adding 166 to both sides. Negative 26y and 3y.
Negative 23y.
Okay, equals negative 28 and then 1 plus 166. That's definitely going to be positive, right? What is it? 138. So now what? Negative 23. 138 divided by negative 23. Oh, nice. Negative 6. Am I done? What do I still lack?
X and your Z.
X and Z, right? Where am I going to take this Y?
You can take the y to the z equals 5y plus.
I could, right? I could take it up here for the Z, or I could take it right here for the X, right? Either one. Well, we eventually going to have to do both, aren't we? Okay. So X equals negative 83 minus 13 times negative 6. X equals negative 83 plus what's 13.6?
78.
Which one is it? 78? And what's negative 83 plus 78? 5?
Negative 5.
And then we already had Z up here, right? Z was defined as 5y plus 31. So if I take the y and put it right there, Z equals 5 times negative 6 plus 31. So Z equals negative 30 plus 31. So what does Z equal? 1. So what's my answer?
Negative 5, negative 6, 1.
And are you sure that that's the answer? Is there a way you could be sure that that's the answer? How? To all of them, right? Take x, y, and z and plug it in x, y, z, see if that's 3. Take y and z and plug it in and see if that's negative 31. Take x, y, and z and plug it in and see if that's negative 21. Does that make sense? Do you have any questions about substitution? How many places in this problem, let me zoom out, how many places is there to make a mistake? So go slow, right? First of all, don't panic. Second of all, know that most of the time you're going to need to substitute twice. When you substitute twice, you're getting rid of one of the variables, and we're here just like we were with 2 variables. Solve for one variable, substitute it into the other. That gives you one of your answers, and then substitute to get your final answer. Does that make sense? Any questions?